All right, we're on part B of this example problem here. We have Gobert the cat, who's frightened by Savannah the cat and jumps 1.1 meters in the air. For part B, we're looking for the total time that Gobert is in the air, the total time. So again, let me go ahead and I'll draw us a little picture to see what's going on. We have the cat right here. Here's Gobert. Super long tail for him. He's jumping up into the air, and then eventually he will fall back down. Okay, eventually he'll fall back down. Well, what we know is he will have some max height. This is our delta x. It's 1.1 meters. And we do know all the way at the top here, our final velocity is 0. That's always nice to know. In addition to that, whatever our initial velocity here is, will have to be the same velocity there. So that's kind of cool. We can use that if we want. So let's go ahead and make our list. Well, we know our final velocity, like I said, that's going to be equal to 0. We do know delta x is equal to 1.1 meters. We're looking for the total time. Okay. We also know every single time, because this is a vertical problem, our acceleration is equal to the Earth's gravitational acceleration, which is, in fact, negative 9.8 meters per second squared. What we know from the previous problem, I'll put this down here as well, our initial velocity is 4.64 meters per second. Now, generally, I always say try not to use this number, because if you use it, you might make a mistake. Let's see what we can do. Well, honestly, when looking at our equations, we need it, right? Because both the first and second equation do utilize this initial velocity. So we're going to have to use it. Now, with the first equation, it does have delta x is equal to v naught t plus 1/2 at squared. And because v naught is a natural number, this actually becomes quadratic, so it becomes extremely messy to solve. So I would recommend using this second equation. V is equal to v naught plus at. Then I'm going to go ahead and use my entire list here. My final velocity is 0. Initial velocity 4.64 plus my acceleration of negative 9.8, and time is what we don't know. These are not like terms, so I do need to move one of them over to the other side. Let's go ahead and subtract the 4.64 over. I'm left with negative 4.64 is equal to negative 9.8 t. I'm going to divide by negative 9.8 on both sides to solve for t. Now I'm going to put a little note down here. This is just our time up, right? It is up to max height. So in my calculator, I got negative 4.64 divided by negative 9.8. Okay, 0.47 seconds. But remember, we are looking for the total time in the air, so that means this is not our final answer. This is just the time up. So what we need to do to turn this into the total time, we need to take this number and we're going to have to multiply it by 2, because the time up is equal to the time down. So for our total time, I'm going to take this number, just multiply by 2 to get 0.95 seconds. This is the total time that Gobert the cat is up in the air.